Assalamualaikum warahmatullahi wabarakatuh and good morning to my fellow friends and also Cikgu Safwan. So today, my group and I are going to present about the environmental science but related with mathematics. So in our member we have me, Hasya, Aidiel, Wong, Vino and Syakira. So the topic that we choose is the calculation of carbon emission. The purpose of our project is to calculate the emission of carbon dioxide gas in vehicles that are in Malaysia.
Okay, next we'll move on into project overview. Our Earth is in a critical condition where global warming is affecting us seriously year by year. This is definitely felt by the rising temperatures felt by the people in Malaysia. This is all due to the greenhouse effect. Thus, we need to contribute together to put an end to this overproduction of carbon dioxide gas.
So let me show you how to calculate the emission of carbon dioxide. So the first thing, you need to have these three main things, which is the distance you travel in kilometer and the fuel you use, and the third one is the emission factor. What is the emission factor? Emission factor is the amount of carbon dioxide that has burned in your vehicles. So the formula will be like this. So the formula of the carbon dioxide emission will equal to the fuel you use times with 100, and you need to divide with the distance traveled in kilometer and times with the emission factor, which is the emission of carbon dioxide that has burned in per liter. So that's all.
Now, given that the problem statement is a group of environmental scientists is conducting an experiment relating to CO2 emission in Malaysia. Their hypothesis is the lesser the number of vehicles, the lesser the volume of carbon dioxide emitted. They experimented using one bus and 10 cars, in which we assume that a bus can fit approximately 40 people, while a car can only fit 4. Now, the scientists want to find whether one bus is more efficient than 10 cars in the context of emission of carbon dioxide when traveling from Georgetown to Kuala Lumpur. Now, given that the approximate distance between Georgetown and Kuala Lumpur is 360 kilometers, but first to calculate the required fuel to travel 360 kilometers, we will have to find the fuel efficiency of a car and a bus. Now, they both have different values because a car is obviously a lot smaller and it's lighter, thus it doesn't require that much of energy. Meanwhile, the bus, on the other hand, it is heavy and it carries passengers, so it it needs a lot of burning of the fuel to do. So, an average car can travel up to 15 kilometers per liter. Meanwhile, a bus can only get far up to 5 kilometers per liter. Now, this is the fuel efficiency value. So the formula for fuel required will be distance traveled divided by fuel efficiency of the vehicle. So for the car, it would be 24 liters to travel for 360 kilometers. Meanwhile, for the bus, it takes up to 72 liters.
After we calculate the fuels needed for each vehicle, we're going to calculate the carbon dioxide emission. So first, we need to know the emission factor of a car when 1 liter of petrol is burnt is 2.3 kilogram carbon dioxide per liter. Meanwhile, the emission factor for a bus when 1 liter of diesel is burnt is 2.7 kilogram carbon dioxide per liter. So now, to calculate the emission of carbon dioxide, we're going to use the formula carbon dioxide emission equals to liters of fuels used times with 100 and then divided by the distance traveled in kilometer times with emission factor in kilogram carbon dioxide per liter. So first we're going to calculate for a car. Okay, liters of fuels used is 24 times with 100 and then divided by the distance traveled, which is 360, and times with the emission factor of a car, which is 2.3. Then we get 15.33 kilograms. Okay, for a bus, the liters of fuels used is 72 and then times with 100 divided by the distance traveled in kilometer, which is 360, and then times with the emission factor of a bus, which is 2.7. Then we get 54.00 kilograms.
With CO2 emission of a bus being 3 times greater than of a car, the bus is able to transport 10 times of the people in a car. How to know which vehicle is more efficient? The bus, which carries around 40 people, releases only 54 kg of carbon dioxide gas. Meanwhile, if those 40 people travel by car with 4 in each car, that requires 10 cars and thus multiplying the emission of carbon dioxide by a car by 10. Thus, the carbon emission of 10 cars would be 153.3 kilogram. Although it is only a small number, this is only for 10 cars. Think about the 2 million cars driving all over Malaysia daily.
Okay, next, conclusion. Based on the hypothesis that the lesser the number of vehicles, the lesser the volume of carbon dioxide emitted. The calculation that we did supports this claim. The emissions of carbon dioxide by one bus is lesser than the emission of carbon dioxide by 10 cars. By decreasing the number of vehicles on the road, traffic congestion is alleviated, fuel consumption decreases, and overall air quality improves. Additionally, innovations such as electric vehicles, when paired with policies to reduce the number of combustion engine vehicles, contribute to further emission reductions. This correlation between fewer vehicles and lower carbon dioxide emissions highlights the importance of urban planning, efficient public transport systems, and cultural shift towards sustainable travel options. Thus, reducing the number of vehicles on the road is an effective strategy for decreasing the carbon emissions and mitigating the effect of climate change. This supports the notion that less reliance on private car ownership, coupled with greener alternatives, can significantly contribute to environmental preservation.
So now I will talk about the innovation to reduce carbon dioxide emission. Our innovation is Green Ride Optimization System. We made an automated carbon comparison for every journey. For example, we can create a mobile app that can allow users to compare carbon dioxide emissions for different transport options. The users can input their journey details, then the app will provide an emission breakdown. For example, the app can compare the carbon dioxide emission between bus and private cars.
Now, here is a real life example of an innovation made by the country Sweden to reduce carbon dioxide emission from vehicles. So this is an app called Commute Greener. It's a mobile app which allows users to measure the carbon dioxide emitted during their daily commutes, whether by car, bus, or train. And it also enables users to set personal carbon dioxide uh, reduction targets and encourages competition among users to lower emissions.
Next, I will discuss about why green ride optimization system is the solution. First of all, it can encourage carpooling and bus usage by showing real-time carbon dioxide savings. Second, AI reduces traffic congestion, further lowering the emissions. Third, government collaboration allows tax benefits for eco-friendly travel. And the last, it can easily scalable across Malaysia, making transport greener and smarter.